Welcome everybody in the lecture hall. Welcome everybody on Zoom. Welcome everybody watching us from the future. Today we will continue what we started last week, which is learning SQL in order to query data. Is actually the meat of the course. We'll probably spend the entire lesson today doing this. It's an opportunity also to come back on anything that might be unclear from previous weeks. So let's start with a question for you. Practice. Oh, doesn't work. Yes, it does. Okay. So this is on the left a table and then a result at the bottom. So this would be the input table, and that's the output of the query that I would like to get. And I'm asking you which one of these four queries would give me this output right here. And so you should go to here. I will show them again, of course, but you can use this code, 65610011. I will alternate between the two slides. So I'm letting you time to connect. Okay. I will show it again, right? So this is the query and the output, the four possibilities and the outputs. Did everybody grab the code of the site? Otherwise, I can show it again. So query 1, query 2, query 3, and query 4. You don't need to actually compute the results of every query. You can also proceed by elimination. Let me quickly take a look at what we have at the moment. I'll come back to give you more time if necessary. So we have a lot of people saying query 2. You can grab the code again if you didn't catch the code, 65610011. I'm coming back to the query. So of course, now you know that a lot of people think it's query 2, but can you convince yourself that it would be this one? Who is done? Completely done. Okay, who needs more time? Okay, then I'm going to confirm that it is indeed query 2. So we have a majority right here. So let's look at the queries. Which two queries can you already eliminate instantly? Yes? Exactly, 1 and 3, because I'm repeating what was said. This one and this one can be eliminated because here we are projecting on A, B, and D. But as you can see in the output, we have A, E, and D, right? So it cannot be this one, it cannot be this one. So it leaves us with this one and that one. Now, if you look closer, how can you eliminate? Well, you notice a difference here with B smaller than C, B greater than C, right? So it's either one or the other. But now if you try to see, it's E is actually the renaming of B, right? So this 2 in here corresponds to this 2 in here. Who agrees? Right? We just renamed B. So the 2 came from here. So we selected, you agree, we selected the second record. In this second record, is B greater than C or is B smaller than C? Okay, who thinks it is smaller? Great, yes, it is smaller indeed. It was just that nobody wanted to answer. So indeed, we have this, and A equals Z. Yes, absolutely, it's also correct. And now if we double check, so it cannot be this one because that one had excluded it. And A equals D would select the first two records, right? If we just use this one, and B smaller than C would select number 2 and number 3, right? The record number 2 and the record number 3. So if we have an AND, the two together, that gives us the second record. Who agrees with this? Right? Now about the null, the treatment of unknown. For the first record, B smaller than C would evaluate to unknown, exactly. So here we would have unknown and A equals D. A equals D is true, so if we have unknown and true, what is the value of unknown and true? Again, unknown. And what happens with the where clause is we only select the tuples for which it's true. So if it's just unknown, that doesn't pass the filter, and so we do not output the first tuple, because we only output those for which we know for sure that the where clause is true. Just as a bonus, so A equals D is not unknown. Do you agree that A equals D is never unknown? There's no nulls in there and there's no nulls in there, right? So A equals D is true or false, but it's never going to be unknown. So it means that A equals D is not unknown is always A equals D is not unknown is always. Who thinks false? Who thinks true? Yes, indeed, it's always true, right? It's never unknown, so it's always true that it's not unknown. Okay, so that was a small rehearsal. So now you see with SQL, you know, select from where, which is probably the most famous part of SQL that many people know about, right? Select from where. And now you see all the subtleties with 3 valued logic, 3 false unknown. You see the projections and so on. Okay, then, so congratulations for this. And now we'll continue where we left off. So in this select from where, we saw that we can squeeze expressions in there. It's very powerful. We can have comparisons with equality, smaller than, greater than. We can have arithmetics with addition, subtraction, multiplication, division, modulo, power, square roots, trigonometric functions, sine, cosine, and so on and so on and so on. There's a huge number of things that you can write in there, both in the where clause, that can be very complex expressions with a lot of different things, and in the select clause as well. You can create new columns by just computing stuff with expressions. That is what we call a mini functional language, the expressions in SQL. It's like a Lego game. You can just combine, just like you would do with mathematical formulas, you could just combine all of these things. For whom is this clear? Right? Very good. So practice is the best way to approach this, right? Of course, you'll have the documentation at the exam, right, of all of this, so you can look it up. Hi, Martin. All right. So I quickly finished over this slide, but then it rang, so I just want to make sure that it's clear. What you see in here are 3 different ways of doing the same thing. This is basically how you create these special types, right? How do you create a date? How do you create a time, like all of these types? Well, you just specify the type, the target type that you want, and you remember what this is called, the name for this. We kind of encode a date in a string in there, right? You agree it's October 17th, 2025. Do you remember what this is called? The string that encodes a date or whatever other typed value. What is the name for that? 2 of them, actually. On Zoom, maybe? Does anybody remember? Does literal ring a bell? It's a literal, it's a date literal, or it is a date lexical value. Right? So it's whenever we put in a string, there's some convention for writing them with year, month, day. That's called the literal. And then you just put in front or after with a double colon the target type. And of course, it has to be correct. If you put here something that's not a literal for a date, then that will not work, right? So pick whatever you prefer. It's basically all the same in here, right? So you can, that's called a cast. If you can actually also put an expression in there, and these here are the two others, right? Just a matter of preference. Okay. And this just meant the case doesn't matter, once again. Right? It doesn't matter if it's uppercase, lowercase. It's just all accepted. So this leaves us with our select from where, with all of these expressions, with selection, projection, and renaming, sigma, pi, and rho. Right? So if we have a select from where, and you look at the relational algebra, what is the select from where doing? Well, it's taking a table. From is basically just getting the table. Then you apply sigma to select the records that you want to keep. Then you project the records that you're interested, the columns that you're interested in keeping. And then you rename the columns depending on the as specifiers. Who is with me on this? Right? And so if we want to represent it as a tree, of course, it's a rather thin tree, but that's how it would look like as what we call a query plan, right? That's what would happen on the computer when you execute the select from where query. Sigma, that's the where clause. Pi, that would be the columns listed in the select clause. And rho, that would be the as aliases. Okay. Generally, there is a correspondence that you need to understand between four different worlds. There is, of course, the world of English. That's our everyday language, right? You might have an English sentence like, I want to look for the first and last names of all people aged 65 and more, even in any language you want. Then there would be the relational algebra formula, as we saw last week and 2 weeks ago, that computes it. Do you agree? This computes this? Right? This relational algebra formula. This would be the query plan that actually corresponds to that formula. It's more like an actual data flow on a machine that basically computes this. And that would be the SQL query that does the same. All these four are different worlds, but eventually they do the same thing. They solve the same problem, right? So the SQL is what you would put in your Jupyter notebook. The relational algebra expression is what you would write on a piece of paper or on the blackboard when you study the theory. The query plan is what PostgreSQL does for you in the background without you needing to bother about it. And English is basically when we ask you the question at the exam of what you're supposed to solve, right? So we'll formulate a problem in English, and then you have to figure out the SQL query to write, right? And now, of course, we are in 2025, and now it's been 3 years that we can actually put that in ChatGPT or whatever AI, and it's amazingly good at writing the SQL query. Who has already tried that? It works really well. Who has tried that? Some? You should. I really recommend. Try. You give a schema to ChatGPT or whatever, or Claude or Gemini or Perplexity, whichever you want. Say, you know, this is a table with these columns and these types, and I would like a SQL query that does that. It will not only give you the SQL query, it will even explain to you why it uses the select and the where and so on, all the reasoning behind this. It's really a great way to also practice with some coach, some automatic coach on the side, right? Of course, it doesn't replace us and the TAs, and we are here to answer questions, but I really recommend you try it out. I actually tried also to, you know, to just put the exam in ChatGPT. It solves it. So maybe with some mistakes, but it's quite impressive. Okay. So let's continue with other features then. Sorting. Sorting requires which flavor of the relational model? Set, bag, or list? I think the question is yes? List, exactly. We need the list because the list has an order. And indeed, PostgreSQL supports lists. And it means that we are able to ask PostgreSQL in SQL to list the records in an order that we want, right? And for this, we use yet another clause. In addition to select from where, we have order by. Order by allows us to specify a column or multiple columns or an expression by which we wish to sort. In that case, by birth dates. So you see 2233, 2324, 2230. So it will be this one, then this one, then this one. Right? Now it's sorted. So you see it's exactly the same thing because I said select star, right? So I have exactly the columns without any changes. I just reorganized the records ordered by birth date. If that were set or back semantics, that would not change anything. But with the list semantics, it actually changes. And so the idea, if I want to give you an intuition of PostgreSQL, it's kind of a hybrid form between set, bag, and list. So the simplest way of putting that is that unless you use order by, PostgreSQL uses bag semantics. Unless you use order by. If you use order by, it's going to switch to list semantics, and then it guarantees you the order. But if you don't have an order by, PostgreSQL is going to consider that it has full freedom of putting things in any order it wants, whatever makes it faster, right? So it has full freedom. But the moment you say order by, it switches to list semantics, and then it honors your requests, right? And it preserves the order. It can switch to set semantics if you use, for example, distinct, select distinct, or if you put primary keys in your schema. Of course, if you have a primary key in your schema, then that cannot be back semantics, right? It's set semantics then. Okay. Very good. Now, by default, it's ascending, right? But you can also specify it explicitly with ask. It can also be descending, right? Then you just put it the other way around. But then, whenever you have a feature like that, you also need to specify what to do with nulls, because you might have nulls in the columns. Do you consider them as the smallest or as the largest values? You want to put them first or to put them last? Well, in some languages, you say nulls are the smallest or nulls are the greatest. In SQL, we prefer to say they come first or they come last, which for our brains is easier to process, right? So if I say order by last name, nulls first, then you see the last names, it's Crusher, Kirk, C, and then K, and we say nulls first, so the record that has a null as a last name will come first, right? Who is with me? Right, okay. You can, if you prefer nulls last, of course, then you can also put it at the end, right? So you can combine ask and desk and nulls first and nulls last, right? By default, if you don't say anything, it's going to sort in an ascending order, putting the nulls at the end. If you specify ascending, then it's putting the nulls last. If you specify descending, it's putting the nulls first, right? It basically means, if you look at the logic of this design decision here, it's basically that by default, it considers that nulls are the greatest values, right? Because it puts them last if it's ascending and first if it's descending, okay? If you're sure, just specify explicitly. If you're unsure, sorry, just specify all of that explicitly. Okay. It doesn't have to be a single column. You can also have expressions. And by expression, I mean everything that I threw at you. Arithmetics, logic, casts, type conversions, with literals, comparison, trigonometric functions, and so on and so on. The whole thing, you can use it in the order by clause as well, just like in the where clause and just like in the select clause. This here, the double vertical bar, is yet another one that I haven't shown you. It's concatenation of strings. It just puts the two strings and concatenates them, like concat in Excel. So here we order by a concatenation of first name, last name. I put them on the left outside of the table, what it is, Beverly, Crusher, James Kirk, and null, because if it's null, then one of them is null, the result is null. And if I order by this, do you agree that I'm getting what you see on the screen? Who agrees? Right? And notice the nulls are at the end because it's by default ascending, right? Okay? Now, yet another feature. I'm keeping pushing. Yes? Yes?
In this example, doesn't matter what the last name is.
Yes, it's true. Yeah, I just wanted to show you an example of expression. I could have built a table with several people with the the same last name or something more complex. Yes, absolutely. Yeah, I just needed to come up with an example, but maybe I could even improve and find another example that is more interesting, that doesn't just do first name. Right. I just wanted to show off that, you know, there's all these expressions that you have in the order by clause. Right. Sorry. Yes, go ahead. Yeah, that's the concatenation of strings. So you see, for example, first name, last name. Look here. First name is Beverly. Last name is Crusher. And the vertical bar does this. It basically creates a string that has the two one after each other, right? Can be convenience. Does that answer your question? Yes? Awesome. And of course, if it's null, then the result is null. Now, there was something else to your question that I wanted also to say. I think I forgot about it. No, it will come back later. There was something else that I wanted to add. All right, so you can put any expression you want here, and it's going to sort by it. So now the next feature that I would like to add is extremely important for the exam, for not crashing the machine. Because when you just do a select from where on some real world data, there could be thousands or even millions of records, right? And so if you try to do select from where in the Jupyter notebook with that many records, that might overload the notebook because it's going to try to put everything on screen, right? There might be some libraries that take only the beginning of it, but that can really overload your computer and distract you at the exam. And so for this, there is the magical word limit. Limit to just say, I only want the first two records, right? So that's what happens here. We order by birth date, right? And ordered by birth date, the first two that come are 2230 and 2233. And since we do limit to, then the third one is not output, okay? Very important for the exam. Use that to make sure that you don't have too big outputs. Okay. By the way, you can the way we crash when we test the exam environment and try to crash the machines, we use Cartesian products. We take several big tables and we do Cartesian products between these tables, and usually it manages to crash the machine, and then that allows us to check how to either restart it or reset the kernel on the Jupyter notebook, depending on how severe it was, right? But basically, do not do it, right? Do not try on exam day to do Cartesian products or that sort of things. In the worst case, we'll reset you on another machine, so it's nothing tragic, but still that's a bit of a distraction to be reseated, right? Yes? I don't think it's an issue, then it will put everything. If it's, yeah. Do you have a microphone, by the way? Yeah, maybe I can give you the, because I realized that people do not hear you on Zoom. So the question was, what happens if the limit right here is larger than the number of records? Then you put them all, right? That's, it's not limiting anything, okay? A very good example of that is the results of a search engine when you have limit 10 gives you the first 10 pages under Google, right? That's an example. Yes? Yes, it does. It has to be in this order. It has to be first order by. Oh, I'm too far away, I think. It has to be first order by and limit, right? I will again. Sorry? So basically, you're asking about hypothetically if it would allow us to do it. It doesn't, right? You would not be able to do it if you put limits to and then order by birth date. That would be an error. But there are query languages that allow you that relax the order, that are a bit more modern. In these other languages, then it would just take the first two, which before the order by would be a bit arbitrary, right? Or maybe an original order in the collection, and then it would order these two. But what I'm saying here is hypothetical because in SQL you cannot do that, right? In SQL you really have to put limit after the order by. Okay. In fact, you can really learn it by heart because there is a strict order. It's select from order by limit. You cannot swap them. You cannot do it in any other order. Right. So you have to learn it by heart. I'll have the complete list in a moment because so far we have, if you want the complete order, select from where order by limit. It has to be this order. Some are optional, but it has to be this order. Okay. And I'll keep adding more and I'll tell you the complete order at the end. Does that answer your question? Yeah, awesome. Okay, limit 2. So limit 10 is typically when you do a Google search and you get the first 10 results, that is a limit 10. Now, what if you click on next on the Google search and go on page 2 where you have results 11 to 20? This is achieved with another clause that is called offset. So here there was an offset of 0, so that's the default. Do you see what happens here? Offset 1 means I skip the first one and I take the next 2, right? So I'm just Kirk becomes now the first in the output and then Crusher is the second to be output. Who is with me? Right. So who could tell me then the limit and offset of the second page of the Google results? How do I get the second page of Google results? What values for limit and offsets? Yes? Limit 10 and offset 10. Did you also want to say this? Sorry? Oh, it could be so. One might think that one has to put the limit like offset 10, limit 20 or something like this, but it's really, limit is really the number of outputs in the outputs. Right. Okay. So limit offset. And then, of course, you have limit limit 10 offset 20, limit 10 offset 30, limit 10 offset 40, and so on and so on. And that's called pagination of the query results, right? So with limit and offset, you can paginate the outputs of your query. Very good for a website. Imagine you're a web shop and you want to, some people are searching for items they want to buy. Then you are going to use limit and offset to show it on a single page, and then they click next and you change the offsets to show them the others, right? So very useful practically. Okay. If you don't specify anything for limit and offsets, then by default, limit all. It shows everything, and offset 0. It doesn't skip any records at first. Okay. Something related to the question you asked earlier, you might ask what happens if there's no order by. If I just say select from limit offset, that would work. But you need to understand, as I said before, that if you don't have an order by, we don't have list semantics, we have back semantics. And that means that when you say to PostgreSQL limit to offset 3, what is PostgreSQL going to think? It's going to think, well, I can just give any 2 records and that does the trick, right? So probably it's just going to take the first 2 and that's it. And the query is correct because you have no order, right? So you should not do this, is what I'm telling you. It's highly unpredictable. It just gives full freedom to PostgreSQL to output any 2. And it doesn't make sense semantically because, again, query limit and offsets are normally supposed to be used with order by. Okay? Who is with me? So this is what we have so far, and I encourage you to learn that by heart in exactly this order. Select from where order by, limit, offset. Select from where order by, limit, offset, in that order. In other query languages, more modern, we can swap the order of the clauses, but not in SQL. Okay, so if everybody is with me, we still have even a bit of time before the break. Then I'm going to move on to yet other clauses because there's more. There's more. Now we are going to look at aggregation. Do you remember the Greek letter? What was the Greek letter for aggregating? on Zoom? You remember the Greek letter we used? Gamma, we used gamma. This one, gamma country city, some price and so on. Who remembers this from last week? Who doesn't remember this? Okay, then I'm going to make sure to explain to make sure that everybody is on the same page. So what we are doing here is we have a table with countries and cities, and you see they repeat. We have 2 records with Switzerland, Zurich, Germany, Berlin, Germany, Frankfurt. And we'd like to group them. So the 2 marked in yellow should be together, the 2 marked in green should be together, the 2 marked in blue should be together. And in the groups, we would like to aggregate the values. So in that case, we'd like to compute the sum here, and we would like to compute the count here. So we'd like for the yellow group this plus this, for the green group this plus this, and the blue group this one is alone. Here we want to count, so that would be 1, 2, and 1, 2 for the green, and just 1 for the blue. We are just counting. So that's what we want to do. And the way we do that is that we specify for our aggregation the grouping keys. So this is how to make the groups. So we say it's country and city. Whatever has the same country and the same city is in the same group, right? So these are my grouping keys. And for the other attributes that are not grouping keys, if I want them, I have to aggregate them. So I'm saying I aggregate by sum the price, and I call the result volume. So here you have, this is the sum of the yellow, this is the sum of the green, this is the same. And here I have count. So I have 2 records in the yellow group, 2 records in the green group, and 1 record in the blue group. Who is with me? Right. So that is the gamma operator. That is an aggregation. And in SQL, we use group by to do that. And these 2 keys here that you see, country and city, so we just put them in the group by. In that case, instead of country and city, I'm using century. So I group by century. And then, of course, I want to output the century. So how many distinct centuries are there? 23 and 24, right? So here I have 23 and 24, 1 output record for every group. And here I aggregate. Count star just counts the records, right? So how many 23s? I have 2 of them, and I have twice 24, so that's 2 and 2. Who is with me? That is a group by clause. The group by comes after where and before order by. So it means select from where, group by, order by, limit, offset, in exactly that order. Okay? So let's now just dive in a little bit more into the sort of things we can do. Very important thing that you don't have to do, but you should really do it. The grouping key that you have in group by, always also put it in the select clause, right? So it should be something automatic for you. You group by something, then you also put it in the select clause. This is called the grouping column or a grouping key, and it appears in here. So you see this is what you grouped on. The other columns are non-grouping columns. They are not in the group by. These columns cannot be put directly in the select clause. That doesn't make any sense, right? And so you have to aggregate them. Imagine that as a counterexample to show you that it doesn't make sense. Imagine I'm grouping by century, and here I try to put age in my projection, even though age is not a grouping key, and I'm not even aggregating. There is no sum or count or anything. Do you see the problem? You basically have the 2 groups here, but then what do you do, right? That doesn't make any sense. What do you put in there? There's 2 values here, 2 values there. That makes absolutely no sense. So in the select clause, you need to have the grouping keys and aggregated versions of the other attributes, always aggregated. So do not ever do what you see on the screen right here. This is how you need to do it. You need to aggregate them by specifying an aggregation. So here I can aggregate with count h. So this is going to be 2 of them for 23, 2 of them for 24. Now, a common question is what's the difference between count h and count star, that I had a count star in here, right? So what is the difference between the 2? The difference is that count star will just count all of the records, not even looking at them. How many records are in that group? Count H is going to count the non-null values of H. So if there's a null, that's not going to be into the count. That's the difference between count star and count on an attributes. Who is with me? Right? So let me show you an example. If I now have count of middle initial, and then you see middle initial has nulls in there. 23 has a count middle initial of 1. And I can see that because if I look at 23, that's this one and this one, and I go all the way to middle initial, how many non-null values do I have? How many records with a non-null values? Only 1. And here 24, how many records with a non-null value for middle initial? Only 1. So I have 1 and 1 here. With count star, I would have had 2 and 2. Okay? So that's the difference. Count star would be 2 and 2. Okay. Now, I told you 2 weeks ago when we looked at aggregation that count and sum are only some of the ways you can aggregate. You can also aggregate with average. You can aggregate taking the minimum. You can aggregate taking the maximum. If you're a statistician, you can aggregate with the standard deviation, the skew, or whatever quantities you can compute on a sequence of numbers. If you have Booleans, you can also aggregate with universal quantification or existential quantification. Not sure that I'm pronouncing it correctly. Bool AND would basically aggregate all the Booleans with AND. So it's going to be true if everything is true. Bool OR would aggregate the Booleans and put false if everything is false and true otherwise. String ag is like this double vertical bar all over the place. So you just aggregate and concatenate everything into a big string. There is a question over there. So there are others. Subtraction, if I'm trying to think about it, the subtraction, the problem is that it's non-commutative. So basically, when you have aggregations like that, typically an aggregation operator, you would like it to be commutative, that it doesn't depend on the order. If you would consider a subtraction, imagine that you have two values A and B, so it could be A minus B or B minus A, but there's two possibilities. If it's A, B, and C, then you would basically have to choose between A minus B minus C or A minus parentheses B minus C. So this is the reason why you wouldn't have a subtraction or division in there, right? But multiplication could be. You could absolutely have a multiplication and it's the product of everything. I do not know if SQL, if PostgreSQL specifically has this one, but you could still fake it with sum and log. Do you see this? If you take the log, then you sum the logs with an aggregation and then you exponentiate again, then you would get a product, right? That would be the big pi. So there's a lot of them. There's really a lot of aggregation functions that you can have. And typically, if you look at the documentation of a database systems, be it PostgreSQL or others, there is typically going to be a page somewhere with a huge list of all the functions that you can aggregate with, right? It's a varying list, right? So very good question. Some of them make sense because they are commutative. If they are not, then a bit more caution. Okay, any other questions? Yes? It doesn't give you an error? Oh, it does give you an error. Yeah. That is because if you just say sum star, you don't know if you're summing this or this or this or this, right? So normally when you aggregate, you really have to aggregate a column. It has to be a column. The star is an exception that is only for count. Count is the only one that can have a star. All of the others, max, min, sum, average, and so on, they all have to specify a specific column, right? Imagine that there's two columns with numbers. if you just say some star, then PostgreSQL wouldn't know if you intend to aggregate the first column or the second column. Right? Does it make sense? Huh? So count star is a very specific exception for count. That's the only one that is allowed to have the star in there. Okay, any other questions? On Zoom, any other questions? Right, okay. So here are a few examples. Minimum age, you see? We group by century here, so 23, 23, the minimum is 57. And here, the minimum is 35. If I have the max, the maximum would be 189. And here, yeah, they live very long in Star Trek. And the maximum here is 41, right? Then you have the sum of the ages, that would be this plus this and this plus this. And you see, I cannot put a star in there. I really have to have the column. Sum and average of the ages, the average between the two, the average between the two. Bool end, that's an example. So I put, I put some booleans in here, and I have a bool end. It means that it's doing end. So you have, if I have 23, 10, 23, that's true and false, which is false. And the second one is that false and true, which is false, right? So that's bool end. Bool or would say true or false, which is true, and here false or true, which is true. And here a string ag, finally, where you have 23, 24, so it's aggregating with the double vertical bar the first names. And for a convenience, you can put a separator, meaning that it doesn't just aggregate them, it also puts in between these comma space, right? So here, 23, let's look at the first name, that would be James, comma space Spock, James, comma space Spock. And here, Beverly, comma space Catherine, Beverly, comma space Catherine, right? And of course, it could be 10 or hundreds, could be many more than just two. Who is with me? Okay. All I did is show you aggregation functions, right? So min, max, sum, average, bool end, bool or, string ag, and there are many, many, many more that might be more advanced. The most common ones, if you really want to learn some of them by heart, these are the ones in here. That's the 5 that are the most commonly used. You can learn that list by heart. Right.
What happens if the aggregated string is longer than the specified attribute, for example, char30?
Yes, very good point. So the question is about the type of the computed value, of the aggregated value. Let me generalize your question. So you asked it specifically for string ag and the length of the string. Let me give you another example of similar question. What if you have a column that has integers and you're computing the average of these integers? Do you agree it might not be an integer, right? Well, in this case, PostgreSQL might use a different type for the result column, right? So in the case, I think I even might have shown it before. Oh, now I was on the Zoom window, that's why. Just checking I have a bit of time, yes. Yes, do you see what I did here? Sum has integer, because the sum of integers is an integer. For average, I didn't put integer, I put numeric. Right. And in fact, the specification of PostgreSQL, I can even find the page for you if you want after the lecture. There is a page in the PostgreSQL documentation that specifies for every aggregation function what the output type is going to be. Right? And it doesn't have to be the same as the input type. Now, in the string ag, I didn't really pay attention when I did that. I just put text. Text is basically infinite. So an open question that we'll investigate is, does PostgreSQL specify anything if we have varchar of a limited size? What would be the output type of string ag? If it would be just text to make sure that it doesn't overflow. And that we check, right? So did I answer your question?
Yes, thank you.
Yes, awesome. So you deserve the break. You followed very well. So let's take a break and I'll see you in 15 minutes to continue this.